Hi everyone, and welcome back to educator.com. In this lesson we're going to talk about circuits and electrical meters. It should be a fairly short lesson. Our objectives are going to be to identify the path and direction of current flow in a circuit, drawing and interpreting schematic diagrams of circuits, and effectively using and analyzing voltmeters and ammeters. So, electrical circuit is a closed loop path through which current can flow. An electrical circuit can be made of most any materials, but practically speaking, circuits are typically comprised of electrical devices, things like wires, batteries, resistors, and switches. However, if you're not careful, even humans can be part of an electrical circuit, so let's try and avoid that. Now, conventional current flows from high potential to low potential. But if you ever want to talk about electron flow, electrons are going to flow in the opposite direction. So electrons flow from low potential to high potential. But conventional current flows from high potential to low potential. So, circuit schematics are two-dimensional representations of three-dimensional physical circuits. Looking at a physical circuit, things can get complicated in a hurry. A circuit schematic is a way of representing that on paper or on a computer that allows us to much more neatly organize what we're going to do with that circuit. Symbols represent the circuit elements, and lines represent wires, conductive wires. Now, sources for potential difference are required for current to flow, and those sources for potential difference can be things like voltaic cells, batteries, or power supplies. And typically we're going to use a symbol for a battery for all of them, where the longer side is positive, the shorter side is negative. And here's how I remember that. When you draw the battery schematic symbol, you have to use more ink over on the longer side. You also need to use more ink to make a plus than you do a minus. So the long side of a battery is the positive side, or voltage sources and current sources can also be used. Here's a single cell. A battery is actually a combination of cells, which is why you get this symbol. A switch, oftentimes shown opening and closing that way. A voltmeter with the V in it measures potential difference or voltage. An ammeter measures current flow in amps. A resistor kind of looks like the Charlie Brown shirt. Variable resistor just means you can change the resistance, and a lamp is a resistor that gives off light. So, current only flows in complete paths. Over here on this side we have the positive side of our cell, the negative side of our cell. We've got a resistor, a light bulb here, but we don't have anything happening. We don't have a completely closed path, therefore current can't flow. On the right hand side though, once we have closed that switch, we now have a complete loop. Current is going to flow this way, from positive potential to negative, from high to low potential. Now, keep in mind though, that means that the actual electrons are flowing in the opposite direction. Voltmeters measure the potential difference between 2 points in a circuit. They're connected in parallel with the element that you want to measure. And if a voltmeter is connected correctly, you can remove it from the circuit without breaking the circuit. So for example, as we look at this circuit over here, the voltmeter would measure the potential difference from one side of our light bulb to the other side of our light bulb. And if we want to make sure we've got it installed correctly, imagine what would happen if you cut the circuit there and there. When you do that, the circuit would still operate. The voltmeter wouldn't measure anything, but you'd still have an operating circuit. If that's the case, you've done it correctly. Voltmeters have very high resistance. They have that high resistance so that very little current flows through them and they don't impact your circuit performance much at all. Just a tiny amount, a negligible amount. You want it as little as possible so that you get an accurate reading of how the circuit would function without the voltmeter in there. Ammeters, on the other hand, measure the current that's flowing through an element of a circuit. They're connected in series with the circuit so that whatever current is flowing has to flow through the ammeter so that you can measure it. You want all of the current that you want to measure to flow through the ammeter. The ammeter must be broken to correctly insert an ammeter. If you can pull the ammeter out of the circuit and the circuit still functions, that portion of the circuit, then you've done something wrong. Ammeters have extremely low resistance. Therefore, they don't have much potential drop and they minimize their effect on the circuit as a whole as well. So let's talk about ammeter and voltmeter placement in a circuit. In the electric circuit diagram here, possible locations of an ammeter and voltmeter are indicated by the circles 1, 2, 3, and 4. Well, right away you should know the voltmeter must be connected in parallel with the element you want to measure, in parallel with the resistor. One more. Which statement about ammeters and voltmeters is correct? The internal resistance of both meters should be low. Well, no, that's not the case. If a voltmeter had very low resistance, it would have a lot of current going through it and we'd probably burn it up. That's a bad answer. Both meters should have a negligible effect on the circuit being measured. Well, yeah, we kind of want that negligible effect. We don't want the voltmeter or ammeter to impact the performance of the circuit. We're going to use these as tools to help us understand what's going on in the circuit as if we didn't have them there. So B looks like a good answer. Let's check C. The potential drop across both meters should be made as large as possible. Ooh, if you do that across an ammeter, because it has so little resistance, you're going to have a ton of current going through it. You're going to make it nice and toasty and probably melt it. That can't be right. And the scale range on both meters must be the same? Well, that's just silly. We haven't even talked about scale ranges. So our best answer here is B. We want the meters to have a negligible effect on the circuit being measured. All right, hopefully that gets you just a very brief introduction to basic circuits and how we're going to use meters, electrical meters, voltmeters and ammeters to measure their performance. Thanks so much for your time and make it a great day.